In A-level chemistry, another way to calculate enthalpy change of a reaction is to use mean bond enthalpies. So, mean bond enthalpies basically refers to energy needed to break covalent bonds in a molecule to turn it into gaseous atoms. One thing to remember is that for this definition to hold true, the substances must end and start in gaseous state. And the word mean refers to bond enthalpies being averaged over a range of molecules. So, in general, the formula to calculate enthalpy change using mean bond enthalpies is the sum of the bonds broken subtracted by the sum of the bonds made. And this is assuming that substances are in the gaseous form. Remember that in a reaction, bonds are broken in the reactants and bonds are made in the products. So a question which is commonly asked is that are values of delta H calculated using mean bond enthalpy more or less accurate than using combustion or formation data? So the simple answer to this question is that answers calculated using mean bond enthalpies aren't as accurate as using formation or combustion data. And this is because mean bond energies are averaged over a range of different compounds. Therefore, they are not that accurate. Here's a question for you to try. So the question says, the mean bond enthalpy data is shown in the table. Use the data in the table above and the equation to calculate a mean bond enthalpy for the OO double bond in an oxygen molecule. So how I like to answer these questions is I like to draw out the molecules to actually see which bonds are present. And in the bonding topic of A-level chemistry, you will learn how to draw these molecules. So the reaction says that ethanol plus oxygen gives us carbon dioxide and water. And this is how I would draw the molecules. Second step is writing down the formula for enthalpy change, which is delta H equals bonds broken, take away bonds made. And remembering, bonds are broken in the reactants and made in the products. Now, looking at the molecules, we can see that in ethanol, there is 1, 2, 3, 4, 5 CH bonds. Therefore, there are 5 CH bonds which are broken, and there is also 1 CC bond, 1 CO bond, and 1 OH bond. And in the oxygen molecules, there are 3 O double bonds to be broken. So these are all the bonds which are broken. Now we have to look at the bonds which are made. So the bonds made are 2 carbon dioxide molecules are made. But in the carbon dioxide molecule, there are 2 CO double bonds. Therefore, in total, there are 4 CO bonds. And there are also 3 water molecules which are made, but in the water molecule there are 2 OH bonds. So in total, 6 OH bonds will be made. Now we can use our mean bond enthalpies and sub in the values. So total bonds broken are 5 times the bond enthalpy of CH, which is 412. Add the value for CC, which is 348. Add the value for the CO bond, which is 360. The OH bond, which is 463. And 3 OO double bonds, which we do not know. So adding all these together, we get that the total is 3,231 plus 3 OO double bonds. So this is the bonds broken. And the bonds made are 4 times C double bond O, which is 4 times 805, plus 6 times OH, which is 463, which gives us a total value of 5,998. Now, we can use our delta H equals bonds broken, take away the sum of the bonds made, to calculate our answer. So, looking at the question, it says that delta H is equal to minus 1,279 kilojoules per mole. So what we can do is then we can do minus 1,279 equals the sum of the bonds broken, 3,231 plus 3 OO double bonds, subtracted by the sum of the bonds made, 5,998. And then simplifying this, we get minus 1,279 equals minus 2,767 plus 300. And now rearranging this, we get that the value for the OO double bond is 496 kilojoules per mole. So to summarize, what is mean bond enthalpy? It's the energy needed to break covalent bonds in a molecule to turn it into gaseous atoms. Substances must start and end in the gaseous state. And it's mean because the bond enthalpies are averaged over a range of molecules. The formula is the sum of the bonds broken take away the sum of the bonds made to give you enthalpy change. Bonds are broken in reactants and they are made in the products. So values calculated for delta H using bond enthalpies are less accurate because mean bond energies are averaged over a range of different compounds. And if you're presented with a question like this, always draw out the molecules to see what bonds are actually present. Then write down the values of each bond. Then calculate the values for the bonds which are broken and for which are made. And then simply use the formula delta H equals bonds broken, take away bonds made, to get your necessary answer. And that's the end of the video.